Hey guys, welcome back to Ken's Chem Vlog. I think it's Ken's Chem Vlog. I think I said that for the first time correctly. Your boy is actually making the video the same day that the notes were actually covered. This is an achievement. Please give it an applause. You know what I'm saying? Warm up. Do we really have to do this? Oops, sorry. Yeah, so we know how to do this. If you didn't watch my other videos, you should, because then you will be super smart. Like, legit, you will be the smartest person if you watch them. Don't look that up. That is 100% true, but just don't look it up. Okay, so recognize it is an ionic compound. This is kind of a hard way to read it. I don't like reading it like this, so we'll just go over to my notes. How to tell if it's an ionic compound. Obviously, if it contains a metal and a non-metal. If it contains ammonium or NH4 with a positive charge. The first name is metal. It contains a Roman numeral, and it contains a polyatomic or it contains a polyatomic atom. This is because now we are going from name to formula, right? Not formula to name. So when it is in its name form, it will have the Roman numeral there, so it's going to be really easy to tell. Sorry. Anyways, let's keep going. Binary ionic compounds. So this is true for all the methods that we covered in 6.1, but it's a really easy thing, right? This is, I can go over it. Basically, first thing you do, you're going to see this name, right? And the first thing you're going to do is write the symbols a little far apart, okay? And then you're going to find the charges of it. You have to use the chart that I show up here. This doesn't have the actual element names. It was just a quickie that I did. But you know that I think magnesium is in this one, 2 right here. And then bromine would be on the far right side. So I know that's -1 here and +2 here. So we have to memorize that, right? So now the only thing I'm going to do is just cross these over. Okay. So magnesium now has the -1. And bromine now has the +2, right? But we only write it in the answer, so our answer will be MgBr2, okay? We're not going to include these positives or negatives, and we also are not going to include ones, okay? If it's a 1, it doesn't matter if it's -1 or if it's +1. We don't write it, okay? We only write it if it's 2 or greater than 2, okay? So that means this is a finite answer because -1, it disappears. Just think of that. -1 in the answer, it will always disappear, right? So this is called the cross-down method, and it's similar in almost every circumstance. Okay, here's another addition we have to remember. This is Harry. I don't know. That's his name. Okay, so calcium oxide. So we're going to write calcium oxide. Using the chart, we know that calcium is a +2 charge and then -2 right here. So we cross them over, and we're going to get Ca2O2. Remember, we don't add the signs, okay? Now, this is a good answer, but it's not what she's going to give us credit on, right? We can simplify this. Oh, I know, it's really hard, right? It's basically that 2 and 2, it can simplify. They're both divisible by 2. So what would be our answer? It would just be CaO. That's it. Because the 2's are the exact same, so we reduce it. So let's give another example. What if Ca is 2 and O is 4? They're both divisible by 2, so Ca becomes 1 and O becomes 2, right? We're dividing 2 on this side and dividing 2 on this side. So this is how we get our answers, okay? But remember what we say. If it's 1, positive or negative, doesn't matter, it disappears. So our full answer would be CaO2, okay? But if we had like Ca1 and O, sorry, wait. If we had 3 and 5, that doesn't work because there's nothing divisible by them, right? 3 can't go into 5, and 5 can't go into 3. So that's just the answer. But for 2 and 4, we know that they both can go into 2. These are some examples. We really don't need to know this. As you can tell, I'm sorry, we do need to know this, but we don't really need to do them because I got work to do, other work. because we have a quiz soon. I know, I'm crying. Okay, I don't know why I said bionic. Binary ionic compounds with transition metals. So this is an addition. So there's a couple steps. If there's a Roman numeral, then here, let me go over here and show. Okay, so binary ionic compounds with transition metals. First step, use Roman numeral as charge of the metal. So this Roman numeral always is for the first name, or the thing to the left, right? So charge will always go to the copper. That means it has a positive 2 charge, and oxygen has a negative 2 charge, and that's what we know that because we use the chart, okay? So as we can see here, copper has a +2 charge because this relates to this, right? And then O2, I'm sorry, not O2, just O, oxygen has a negative 2 charge because we look at the graph and we memorized it. And if we cross them over, we get Cu2 and O2. So 2 goes to this side and 2 goes to this side, right? But since they're both 2s and they're both divisible by each other, it just becomes CuO. So let's try some. Iron 3 always goes to the thing to the left. So you get +3 up here, and then oxygen we know is -2. So we cross them over. Iron, Fe gets 2, and oxygen gets 3, right? So that would be our answer, because 2 and 3 are not divisible by each other. Another thing on the quiz, she's going to give us the chemical compound, and she's going to ask how many number of atoms are there, okay? In this, we can tell there's 5, because there's 2 here and 3 here, and that's how we get 5. So another example of counting the atoms, if you have PO4, it's kind of like an exponent, you know? If an exponent is like 5 squared, and you square that over the exponent, it's actually 5 raised to the 4th power, because you're doing 2 times 2. Same thing here. So if you have PO4 in parentheses and then you have a 2 on the outside, there's the 2 will transfer to both of them. They'll distribute. So that means if there's 2 here, 2 times 4 is 8, and then 2 times, this would just be known as a 1, even though it's not there, it'd be 1. So that means we'd have 10 atoms. Hopefully that makes sense. We can do these ones, but hopefully you know how to do that already, as I explained earlier. But this has 5, and then this will have 2, I believe. 2 atoms, because it's just 1 and 1, as we know. Okay, ionic compounds with polyatomic ions. We do need to memorize this. On the quiz, she gave us the ones we have to focus on. But it says, in the first name of the formula is a metal, and the second part of the name ends in ate or ite, except for hydroxide and cyanide. They're kind of on their own. The formula contains a polyatomic ion. So you can see up here, ide means binary ionic, and then ite or ate usually consists of polyatomic ions. So it's the same way. Step 1 is going to write the symbol. So symbol for silver is Ag. Symbol for nitrate is NO3. And then the charge of each. So we kind of have to memorize that. We know silver is one of those exceptions on the graph. On the table. So it has a +1 charge. And NO has a -1 charge because I think it's like in this category right here. So we know that has a -1 charge. But we put that outside, right? Because NO3 is the polyatomic ion. So we don't want to interfere with that. We just want to put the charge separate, right? And we cross on the method. So -1, -1. So NO now has, this goes to here, right here, as you can see. And then this -1 goes over here, right? We're not adding the signs, so it might look a little confusing, but this -1 is going to this side because it's crossing over. And then this -1 is going over here and crossing over, okay? So now we have this like big mess with the -1 here, with the 1 here and the +1 here, and then 1 here and the -1. The ones up top are the charges, as we know, but we don't need the charges. So step 3 is write it without the charges, so we can cross these out. And we know, like I said before, that if it is 1 in the bottom right corner, then we disappear. It disappears. 1 is done. you can remember that. So our answer will be AgNO3, okay? That's because these ones are, but we don't need to have them there because we already know it's there. It's like, let's see, like X, right? If you're doing X, we know that it's actually one X in front of it, but it's redundant to put it there, right? So that's why we don't put the ones there, because we know it's there, but it's just unnecessary to write it. Just like X, right? We know X is actually one X, but we don't write it that way a lot, right? Okay, here are some examples. We have the charges, right? 3 goes to this side, 2 goes to this side. Remember, we don't add the charges. I'm sorry, we don't add the signs. And that is your final answer. These both go down, but since they're both 1, one is done and they disappear. That's actually basically it. So I'm pretty sure I sent this to all of y'all, the different hearts, or the different ways. So I only did one, how to tell if it's ionic compound. And these are just like the steps to do it and also the steps to simplify. Yeah, so I didn't add any jokes anytime this because like, yeah, I wasn't, I'm not in a comedic mood. I just, I'm not. I had a sugar rush early today in chem class and it died down, but next one will be way more funny. I swear to God, I hope, okay? It's going to be more funny, but I hope you understood this. It's pretty easy. You can text me separately if you really need help. I can do another video for you, but hopefully this helps. It's pretty simple. It's like, it works for everything, so, okay. Bye.